Wait, you triangle, so it's like
Yeah.
one and one
Right.
root two.
Great. Yes, correct. So here's a story 549, guys. Yeah, thank you, Faith. That was perfect. Yeah, so we know this is an isosceles triangle. And we talked about isosceles triangles early in the year. So when you have, and let's be present to like step by step to see what's happening here. So this is at the very least what you know, right? You know there's a right angle. You know there's a 45-degree angle. And this is, not a total mystery, but kind of a mystery for now. What is that missing angle, right? Because it's not given to us. But if you use your knowledge of triangles, you got 90, you got 45. What's that other angle going to be? It's going to be 45 also. Has to be 45 degrees. That has to be 45 degrees. We have no other choice, right? Because they have to add to 180. So that's just building upon previous knowledge, right? So building upon previous knowledge, we know that now. So this has to be an isosceles triangle, meaning those angles are the same and those sides are the same. So guess what? What does A equal then? Yeah, equals 1, right? So that's 1 now. Perfect. Now for B, how would I solve for B? What do I do? Pythag, yes. I'll bring a Pythagorean theorem. And Zoe and Kier, can you put your laptops away? You don't need them. Thanks. Appreciate it. So 1 squared, and you too, Reagan, you put it away. Thanks. 1 squared plus 1 squared equals B squared. So 2 equals B squared. Was B equal? Root 2. Okay. So there we go. And exact form means we don't want decimals. Just keep it all nice and clean. So we use a little bit of geometric knowledge. Like, yeah, we know about isosceles triangles. We see that there's two angles are the same. The sides opposite are the same. One of the sides is 1. The other side's got to be 1. The hypotenuse, we could do Pythagorean theorem. So what should Darren name this triangle? We can call it a 45, 45, 90 triangle. Just like in the previous page, we had 36, 90. So 30, 60, 90. You have 45, 45, 90. So use this fact for all 45, 45, 90 triangles that are similar because all the angles corresponding angles are the same. In the right triangles below, and leave your answers in exact form. Okay, so this will always be true. This actually, I think, is easier than the 30, 60, 90 because you already got two sides of the same. And the third side, the hypotenuse, is going to involve some sort of root 2 kind of thing, right? So this should go by pretty fast. So for example, I'll call this A and B. I'll call this A and B.
Can you just like
Hmm?
set up a ratio
Yeah.
to solve for each one?
Yeah, 100%. Yeah. And when they get more complicated, we're going to want to do that. 100% we want to do that. So what does A equal for the first triangle? 20. And then using the ratios from before, remember, up above, we had this going on here. So we know these are similar triangles, right? Because the one we just talked about with 1, 1, and root 2 was 45, 45, 90. All these other ones are 45, 45, 90, meaning all the corresponding angles are congruent, are the same. So if A is 20, then what's B going to be for the first triangle? There's going to be root 2. We're going to put in front of that root 2. 20. That's it. Yeah, don't overthink it. Just 20 root 2. Because if you do Pythagorean theorem, it's going to make sense. Actually, let's do it right now. Just to satisfy our
Wait, if I did like a ratio,
curiosity.
then I get like B root 2 equals 20, and then divided by 2 divided by root 2. So then I have B equals 20
Yeah,
divided by root 2.
Oh, wait, sorry, repeat that again.
Like if I did this ratio,
Yeah.
and I feel like it's like B equals root 2.
Yeah, it's still the same thing. You multiply top and bottom by the root 2 to get rid of the root out from the bottom. You'll still get 20 root 2. That's still the same thing.
So I just want to do like.
Hold on to that thought because we're going to do that later today. Hold on to that. So if I do Pythagorean theorem, you get this, right? So then v equals root 800.
Just root two for the one.
So you could do all that, right? But here's the problem. Once you do all that, then you have to simplify it afterwards. So it's 400 times 2. So it's root 400 times root 2. So you get 20 root 2. Like, so what you're saying, Maggie, yes, we can do Pythagorean theorem, 100% we can. Like, totally. Like, okay, we know A is 20 because the sausage triangle, all's good there, right? So it's 20 squared plus 20 squared equals b squared, 800 equals b squared, b is root 800. Well, that's 400 times 2, fine. Plus root 400 is 20 root 2. That's a pretty labor intensive process. I would just use the ratios and say, well, fine, that's 1 and 1 root 2. That's 20 root 2. Just do that. Yeah, go ahead.
So the isosceles triangle, it's always like one side like root 2?
Yeah.
Oh, okay.
So what about the second one? 5 and 5 root 2. There you go. It's that simple. Now it does get a little bit more complicated. That's when the hypotenuse doesn't have root 2 involved, and you have to divide by root 2. That gets a little crazy. We'll talk about crazy in a later in the class. But here are the big ideas. And by the way, this is on the SAT exam itself. They actually give you these ratios. So I think in most likelihood, we'll probably give this to you guys. I think it'll only be fair. But if you just use logic, it's not so bad. So we'll say this is 30 degrees. Therefore, that's 60 degrees. We'll say this is 45 degrees. Therefore, we have another 45 degrees, right? Okay. Here's how we could generalize it. X, 2x, x root 3. X, x, x root 2. So those are called the special right triangles. And we use x because I don't know exactly the side length. But what I do know is that there's a relationship, right? That, oh yeah, the shorter leg, which is opposite 30, is half the hypotenuse. And the longer leg is root 3 times the shorter leg. For 45, 45, 90, both the legs are identical, as they should be. They're opposite the same angle, or same angle measure. So the hypotenuse would be x root 2 if I do Pythagorean theorem. So now we're going to apply this principle to the problems on the next page. So problems on the next page. I did warn you, some of these can get a little challenging. We'll do these one by one. Actually, we'll kind of go around the room a little bit. So, Lucas, I'm gonna have you help me. Part A. Okay. So, what do we know for part A? That's good. I know that too. Well, okay, tell me more. I want more. Tell me more. Yes. And what's the angle opposite of it? Okay. Is 30 degrees a smallest angle here? Yeah, because the other two are going to be 60 and 90, right? So 10 has to be the shortest side. How long will the hypotenuse be? Based upon what we've talked about on the previous page. How much exactly? We said 2x, right, Peter? Well, no, if x is 10, 20, good. It's 20, good. And then what about the other leg? 10 root 3, perfect. Okay.
Where is the root 3 coming from?
That's from the previous page. We just talked about the ratios, right? Okay. Well, okay, let's back up here. No, it's fair. It's fair. Okay, I don't want you just to accept the ratio like, well, this is what Mr. Reese have to do it. So let's back up a little bit here. This is good. This is why I'm asking the questions, because I got to find out what you guys know. All right. So Lucas, do you have this? Did you have this jot down on the previous page?
Yeah.
Okay, good. Let's talk about it. Let's come back to it because this is good. So we have this, right? Now, what if I did this? What if I extended this triangle like that? And deliberately made this x also. I know I didn't do the scale. What if I just flip the triangle over? made another triangle that's identical to it, but just on the other side. So this has to be x, and this has to be 2x. So I'm deliberately making another triangle that's exactly the same as a pink triangle. So if you think about it, how long is the side here? 2x, 2x, 2x. So how do I know the side's x root 3? By doing Pythagorean theorem. If I call this like, say, b, for example, b squared plus x squared equals parentheses 2x squared. You see how I did Pythagorean theorem? B, x, and 2x, right? Each of the legs squared add up to the hypotenuse squared. If I clean it up, don't I get 4x squared here? X squared and b squared. And then how do I get the x squared over to the other side? I should subtract, right? What happens when you subtract? You get 3x squared. Lastly, how do I get rid of the square symbol? I do what to both sides? Square root. When I square root, what do I get? Square root of 3x squared, which is actually, you can square the x squared separately. Oh, because I squared both sides. I did Pythagorean theorem, right? Yeah, that's why it's x squared. Yeah, guys, I'm just doing Pythagorean theorem, right? You guys see how I did the this side squared plus that side squared equals that side squared? Right. And if I isolate b, I wind up getting this. And I get x root 3. That's where the root 3 comes from. It comes from Pythagorean theorem. So it's not some sort of magical thing you just accept it. No, there's actually a reason to it. I think something that you guys have already proven before. So coming back to this one, I know this has to be 20, and I know this has to be 10 root 3 because I'm following the ratio I established on the previous page. We'll do more. I think the more we do, the more this will sink in. Now,
What? 2x. Why isn't that
It-
2x root 2?
for part A?
Just for 30.
No, because again, yeah, no, because remember for 45, 45, 90, you had x and x root 2. That's because when I did Pythagorean theorem, at x squared plus x squared. So guys, let's talk about this. Since Maga brought up a great question. Why is that root 2? Think about it. X squared plus x squared equals x root 2 squared. So that makes sense because the left side is 2x squared. So this is also 2x squared. That's why it's x, and x root 2, because it follows Pythagorean theorem. So for part B, if that's 4, what's this side over here going to be? And this side? Got it. Perfect. That's it. Let's use the same ratio for part C. Now the hypotenuse is 8 root 2. What do you expect the legs to be? Yes. Good. 8 and 8. Perfect. And let me write this over again. Okay, before we move forward, let's check one more time, make sure we got it. 10 root 3 is 20. What happens if you square 10? What's 10 times 10? Okay. If you square this, be careful. You square 10 and you square root 3. What's 10 squared times root 3 squared? What's 10 squared again? 100. 300, right. Because what's root 3 squared? What's root 3 times root 3? 3. So that's 10, that's 100 times 2, so that's 300. What's 100 plus 300s? Great. What's square of 400s?
200.
What? Right. Not half. So that's why it works. Here, if I do 4 squared, that's 16. 4 squared is 16. What's 16 plus 16? 32. Great. So if you have the square root of 32, is that root 16 times 2 or root 16 times root 2? Or 4 root 2? It's following Pythagoras theorem again. So this will always give that reassurance. The next three are going to be a little crazy. So the next three are going to be a little crazy. You'll see why in a moment.
Yeah.
But let me explain what's going on first, and I'll help you guys out. All right. So let me redraw the 36-90 ratios again. And redraw 45, 45, 90. Right. So x, 2x, and x root 3.
Would it be like 9 root 3? 18 root 3?
Not quite, no. I'll explain in a moment. Okay. Okay, hold on. Let me redraw that. I don't like that. Okay, now let's look at part D. Okay, this is the part that might require a little hand holding or spoon feeding. Okay. All right, 9. 9's opposite what angle?
60.
60. 60 is opposite what side here?
90.
Side.
3.
X root 3, good, good. So what you're gonna say is you're gonna say x root 3 equals 9. So x root 3 is in the same position as 9. Because x root 3 is opposite 60, 9 is opposite 60. Now, how do I solve for x? What do I do?
Divide by root 3.
Good. Divide by root 3. Good. Now, this is where no, this is where I need to go back to your middle school teachers and tell middle school teachers you gotta teach radicals, which is why I have that radical packet that I made for you guys that I'm gonna make sure you guys work on during Thanksgiving break for the retake on December 11th, I think.
On the hypotenuse, so this is the also fits in. Now, into
2.
Sorry, like that. Okay. You guys now get rid of root 3 here.
You multiply by
Yeah, yeah, yeah. You multiply top and bottom by root 3.
Oh, I think it's 3 root 3.
Correct. So this is what we call rationalizing the denominator. You're turning the bottom into a rational number, meaning it's a clean number. It has no like nasty radicals and stuff like that. By doing this, you get 9 root 3 over 3. And what does that reduce to?
3 root 3.
3 root 3. So this side here will be 3 root 3. I mean, this is double, that's 6 root 3. If you do Pythagorean theorem, it will work out because you'll get,
Why'd you double that?
it's always double.
Okay.
The hypotenuse is always double the short side, because that's based upon my ratio here. That's what we established. Remember we established earlier, we did this.
Oh, yeah.
And so it's just because we're cutting this in half.
Yeah.
So this is always half of this. Hope that makes sense. This is half of this. So once you have this one, that's a little challenging. I will admit, this is a little not super easy. Once you have that established, then this should be pretty simple. So let's try it again for this one here. This one's 6, that's 30 degrees. How long is that side? 3. And therefore that's
3 root 3.
3 to the correct. Right. And then this one here, okay, you can call this x and x, but if you think about it, 6 is hypotenuse for this triangle, right? The 45, 45, 90.
It equals x root 2.
So 6 and x root 2 are the same thing. X root 2 equals 6. X is 6 over root 2. Multiply top and bottom by root 2 and root 2. You get x equals 6 root 2 over 2, which of course is 3, yes, 3 root 2. Oh, sorry. So each of these are 3 root 2. I do need to check with Mr. Davis and see what he's done in years past. I don't know if he's asking them to memorize this. Personally, I think we should give this to you guys.
Me too.
I think we should get it to you.
Two.
But you have to know how to use it. That's what I care about. How do you use this resource, right?
Yeah, we're going for those like okay, so it's like 60 degrees and 30 degrees. Then the 60 was like
X root 3.
okay.
Yeah.
Okay.
Right. Okay, so we still got more time, which is great. We're doing actually really well in time here. Before I move forward to 522, any questions on what we just did? It'll take time, by the way. You will need to practice this. And there'll be homework on this. You will need to practice this. It's the first time you're seeing it. I get it's not super easy. Yeah, because that was a tad. Actually, you know what? Let's go Delta Math right now. Let's go right now. I think it's a good idea. Okay. since no, you brought it up. No, we should talk about it. So let's have a discussion out. No, don't worry about it. Mr. Davis could see who submitted it. It's all good. So let's talk about special right triangles. Here we go. Okay. Oh, let me erase the board. Okay. So you're talking about this one, right again? This step off?
Yeah.
Okay. So
Equilateral.
you mean the 3690? Or I'll click on the other one.
Okay, so I have.
What's that one called? Yeah, same one.
Okay.
Yeah, same one. I mean, everyone's got different questions. It's randomly generated, but it's the same category. Okay, so 45, 45, 90. That's 4. So this is opposite the same angle. This is also going to be right. So if that's 4 and 4, if I use the ratios, 4 to.
Yeah.
Yeah, so you don't have to do like any SOHCAHTOA stuff. 4 root 2. Okay, let's try a new one here. Okay, so 5 is opposite 30 degrees, right?
Yeah. Like.
Okay, now if you think about it, I could extend it like this, right? Once you get very good, because you don't have to keep doing this work, but if that's 5, that's 5, right? And now you made a equal out triangle. So how long is the hypotenuse here?
10.
They're each 10, right? And if I do Pythagorean theorem, 5 and 10 and x squared plus 5 squared. Turn off your Peter, can you put your laptop away? You don't need it open. Well, guys, all your laptop. No, or if you have Delta Math open, it's okay. If you have Delta Math, it's totally fine. Okay, good. So x squared is 75. X is root, hold on a sec. X is root 75. That'll be 5 root 3. Because 25 is a factor of 75. So you could do all that work, by the way, but the problem is that you're going to drive yourself crazy if you keep doing that work all the time. That's why we have to embrace the ratios. The hypotenuse is double the short leg, and the longer leg is root 3 times the short leg. So when you solve for x, you get 5 root 3. There you go. Matt, go ahead.
What if it doesn't, like, what if it's kind of like the same one, but doesn't give you the angle? Like, you just guess? Like,
Oh, no, you have to know the angles.
Yeah.
Really? Wait. Oh, no, you know it's 16. That's equilateral. You know it is. It says equilateral, right? Yes, you know it's 16. They didn't explicitly state it, but it's implied here. It's equilateral, so.
Wait, if
Yeah.
you do like a ratio, but like in the triangle thing, the longer for a 30-60-90
Right.
triangle, that side is x root 3. Is that what it is?
Correct. Correct.
Okay.
Okay, let's move on to 522, guys. Let's keep moving. Because I want to get to at least halfway through. All right, if we can get to the end of page 3, that'd be awesome. I think we can do it. Okay, so let's move on to 522. Okay, Pythagorean triples. So far you've learned how to find missing sides. If you know shortcut, share with your team. So what I'm gonna have you guys do, I'm gonna have you guys next to whoever you're sitting next to, work these out. I'll write the ratios off to the side. Now some you can do Pythagorean theorem, just so you know. If you know 2 sides, just use Pythagorean theorem, like for part C or part F, or even part D. Use Pythagorean theorem. Sometimes you have to do this. X, 2x, x root 3. Remember, the x root 3 makes sense if you do Pythagorean theorem. If you're still having a hard time seeing it, do Pythag, it will make sense. Pythag will confirm it. And then, of course, same thing over here, but this is for 45, 45, 90. let me make that a little nicer.
The first one's for 3069.
Correct.
What's root 3, root 2?
Root 6. I think I know what you're talking about. Yeah, when you have two radicals you're multiplying, you can put underneath one radical. Like, for example, if I have root 4 times root 9, that's root 36, which is 6. But if you did it individually, 2 times 3 is still 6. So you have, that's a property of radicals, which, again, it's a little disappointing that it wasn't really covered in middle school. It's you know, I think it's just most middle schools don't cover it. It's nothing against your middle school curriculum. Just I wish they did cover it because it makes my life easier. So we're kind of learning by the seat of our pants, unfortunately, sometimes. So anyhow, try these 9. I'll walk and help you guys out. And then we'll check in about 5 minutes or less than that.
I was struggling without math last night. I don't know why. I just like can't.
Yeah.
I can't do that. I use like can't stuff. I can't do like 60 words, like the 30, 60, like perfect. That's just so I like.
Well, we're gonna practice it now. Yeah. Right now is gonna help you. Any questions so far? Is it okay? Is it okay?
I have a question.
Yes.
How do you like do a ratio if you have that many variables? Like, how do I find
No,
it?
you're overcomplicating again. A is half 12. That's half 12. What's half 12?
But it's 36.
Exactly.
6 is the answer.
We know this is half, right?
This is.
I know what you're trying to do. Here's what you're trying to do.
Wait, is the base 6 root 3 though?
Okay, so Grace, I know. Sorry, Kate. Sorry, I don't. I teach Grace, but anyway. Okay, 12 lines of what? 2x.
Yeah.
So is x equal? It's great. So that's 6. Done.
Okay.
You're overcomplicating it. Done.
So like for B, what is it? 3 root 2
Correct.
for the hypotenuse?
Yes, you got it. Okay, I'm gonna freeze the screen for a moment and put my answers up.
So.
Okay. Wait, computer. Do tag and firm. Yes, 3 squared or 4 squared. 16 plus 9 was what? Yeah, how are we doing here? Okay, once you got the book in English. Still want the same thing as well. So, okay, you call it. Okay, so what are you doing? You're able to have the. Well, that's well, maybe 4 squared, 16. Great, which one? Well, this is right, but we got. Good, excellent.
Yeah.
There you go.
That's all I had to do.
Yeah. Okay. Go on.
This, I don't know.
So there's-
I would,
It's
both sides, side.
We're trying to get.
Maybe Vargas is not root.
So I made it submitted as.
Sorry.
All three, what's Thursday?
I assume this is amazing. And then. Correct, yeah.
No, it's a dead eye.
Yeah. How long is this thing?
Dead, dead eye. Dead eye.
I know,
Right,
it's so
but
perfect.
think about it.
Dead eye.
Good. Look, you're all there. Good. Okay. And then now I got to this side, right?
You got one question,
Right. Yeah.
Really hard.
You know,
So you root all of it. Now here's this, we'll probably make that. We'll see what it is.
that would indeed give you.
That'll be 6 root 3.
Yeah.
Because root 36 is 6, so that's why you get 6.
That would be that.
And that's why.
That's terrible. Because
That's
it's
why.
why is.
Okay. That's supposed to be that, right, that you already saw this one. So these are identified.
Yeah.
So this has to be that. And then you hide them.
Oh, wait, no.
no, because
So we're gonna notice that.
Yeah, so-
Root
It's crack.
Three root-
It's 8, so
root
that means.
9, so 9.
Or that means this is 9.
Correct, and then.
This is
reduce
9.
that. That's what we get. So maybe, yes, whenever you see this in the school. So like, we'll do that, acquisition of students. Now, you have, yeah. Yeah, keep going, keep going. All right, guys, we gotta keep moving.
I got one call.
All right. Well, let me show you the first 6. Okay, those are the first 6. So again, we're following the ratios for 36-9 for part A. We're doing 45-45-90 ratio for part B. Again, we're doing 36-9 ratio for part E. But C, D, F are all Pythag. And these are called Pythagorean triples because the side lengths are whole numbers. So they come out nice and clean if you work out CDF. You get those numbers there. Now we move down to I. I'll freeze that for a moment. The people are still copying. Now for GHI, let me do it really fast and I'll show you the answers in a moment. 12. Ugh, that one's kind of crazy. Give me a sec. You should get that for GHI.
Wait. One.
Yeah. Yeah.
Well, that's typically like,
No. Think about it. Just follow it. That's also good.
now it's 6.
6. Did you get that? You should get 6 every 3.
Okay, so for these, like, you don't really need to set up a ratio, you just need to like look at it.
Correct. Yes. Yes. Yeah, because I think you're trying too hard to do that, and that's where you're getting a little flustered. But yeah,
Fine, X.
right. Okay, guys, let's keep moving. Let's look at 560. And I think at this point we'll just finish the second page and we'll do the third page next time. All right, so 560. Here we go. We have someone else read. Connor, can you read 560 about Carl?
Carl noticed some patterns as he was finding lengths of the missing sides of the triangles we found in 550. He recognized that the side lengths of the triangles in C, D, F, G, H, and I were integers. He also noticed that knowing the side lengths of the triangle in part C would help find the length of the hypotenuse in parts D and G. Groups of integer values that make up the sides of right triangles, like 3, 4, 5, and 5, 12, and 13 are called Pythagorean triples. What other sets of numbers are also Pythagorean triples? How many different sets can you?
So, for example, this is one we can say 6, 8, and 10. I know. Thanks. 6, 8, and 10, because you just double the sides of 3, 4, 5. Another one that's kind of not too common, but you can see sometimes is 8, 15, and 17. I could do more, but I think, how many different sets you can find? It's obviously infinite. There are infinite possibilities. Yeah, you can do that because you're doing proportions, sure. There's a whole bunch of options here. Okay. So now let's look at 561. You're asked to find the missing side lengths, work it out. So we'll do part A, B, C. Hopefully you guys are feeling a little more confident with this. Again, don't overthink it. The shorter leg, we now know is half the hypotenuse. So for part A, clearly the one opposite third is a shorter leg. What's the hypotenuse in part A? What's half of 12? So you got 6. And what's the other side here? 6, 3. Okay, let's take a look at part B. You can do Pythagorean theorem. Those are some crazy numbers to do in your head. To do 18 squared plus 24 squared is kind of crazy. But if you think about it, it's kind of like this.
So it's times multiplied by 3.
Yeah, it looks like we're multiplying by 6 every time. So it's 30. Yeah, just so you guys see what happened, you could do Pythagorean theorem if you want, but seriously, I would just do the ratios. You got there. What was the word?
6. Bang, that only works with 36 kids. Yeah. No, this one's super
Yeah.
one.
This one's gonna be 5, 5, and 5 root 2. All right. And lastly, yeah, I don't want to do 562 with like a few minutes left at the end of the day. Okay. All right. I think you guys got this. Okay. So this is the shorter leg. So the hypotenuse must be what? Yeah. If you do this, 7 and 7, that's 14. 7 root 3. Yes. So I think the kind of the drill and kill could help a little bit, and I'll provide over Thanksgiving break. I mean, I already gave you guys a packet, but you guys should, if you're doing a retake, you definitely should practice the radical stuff. That one, we saw that ratio already. That's going to be okay. It's a matter of recognition, like just seeing this enough times. I mean, if you need to do Pythag, it's totally fine. That's not a problem at all.
Like 6.
Yeah, we'll do it in a moment. Yeah. So you get 12. Lastly for this one, if you want, you could do Pythagorean theorem. If you so desire, you could totally do that, and you get 2x squared equals 36. X squared is 18. X is root 18. So x is 3 root 2. You can do all that work if you want, or you could do this. Let that equal x root 2. And solve for x. You'll still get the same thing. Get 6 root 2 over 2. Which of course is 3 root 2. Probably a good place to stop for today. Homework, I think it's some stuff in the CPM book. I didn't produce it. Just look at it on Schoology. Okay. I think we're all set.